So homework question 25, we're given the following information about codeine. Codeine is a base. And to kind of help make this a little bit easier, I think it would be helpful to write out, right, for a generic base, any base is going to react with water to form the conjugate acid. So BH plus and hydroxide. And they tell us that this base, we want to know the percent protonation of this concentration of base. So I've got codeine in solution, and that concentration is 0.0065 molar. We want to know percent protonation. So essentially what they're looking for, we talked about percent ionization for acids. For percent protonation, what we're looking for is how much of this base is protonated, right? That's going to be the conjugate acid. So it's going to be BH, concentration of the base that's protonated, over my concentration of the base times 100. We did this for acids where it was how much of the acid ionized. So what was my hydronium concentration divided by what was the initial concentration of my acid. We can do the same calculation for a base. So they tell us, so one more thing, we've got our KB equals my concentration of the conjugate acid times the concentration of hydroxide all over the concentration of my base. And they made this a little bit harder as well, because instead of giving you KB, they gave us PKB. They tell us that the PKB equals 5.75. I don't need the PKB, I need KB for that expression. So I can find what is the concentration of the conjugate acid, what's BH plus, what's hydroxide. So the same thing that we did before with pH, going from pH to hydronium, we can use to go from PKB to PKB to KB. So we know KB equals 10 to the negative PKB. We need to just get rid of that negative log, right? So if we do 10 to the negative 5.75, that's going to give us the KB value of this base. And that's what we need. So 10 to the negative 5.75. And I get a KB of 1.778 times 10 to the minus 6. Now we can do that calculation. All right, my KB 1.77 times 10 to the minus 6 equals, I don't know the concentration of the conjugate acid or hydroxide, but they're formed in the same ratio. So they both, if I call one X, the other one should be X as well. So X over X, or X times X over my initial concentration, 0.0065 molar. So I'm going to multiply both sides by that 0.0065. So times 0.0065, multiply this side by 0.0065. All right, that cancels out. And I'm going to get 1.156 times 10 to the minus 8 equals X squared. Right, take the square root of both sides because we're looking for X. Take the square root of that. And I get X equals 1.075 times 10 to the minus 4. What is X? X is the concentration of my conjugate acid, right? And that's what I'm looking for to find my percent protonation right here. I'm going to plug in the concentration of my conjugate acid divided by the concentration of my base and multiply that by 100. So conjugate acid divided by base times 100. My conjugate acid concentration, 1.075 times 10 to the minus 4 divided by 0.0065, my initial concentration, times 100. And that should give us our percent protonation. So divide that by 0.0065 and multiply that by 100, and I get a percent protonation of something like, 1.7% for that base. So we did very similar problem in class, except for we did this calculation for an acid. It was just percent ionization. So we can do the same calculation for a base. It's just a little bit more involved because of that. And they also made it a little bit more complicated because instead of giving us KB, they gave us PKB. So we had to do one more extra step to go from PKB to the KB. We had to get rid of that negative log. So 10 to the negative PKB.